When we want to go faster, we build a bigger engine. We ignite millions of pounds of propellant and let raw, brute force tear us away from the ground. For centuries, our understanding of motion was ruled by simple, intuitive math. If you apply a continuous force to an object, its speed will continuously increase. Keep the engine burning, and you will keep accelerating. That logic created an assumption about our future in space. To cross the vast, empty distances between stars, humanity simply needs enough time and a sufficiently massive fuel tank to push our ships to whatever velocity we desire. But at the extremes of physics, that intuitive math breaks down entirely. The universe enforces a strict mathematical speed limit on every piece of matter in existence, and no amount of engineering can push past it. That limit is exactly 299,792,458 meters per second. In a vacuum, this is the absolute maximum velocity allowed by nature. In the 1860s, James Clerk Maxwell identified light as a wave of oscillating electric and magnetic fields. He realized that all forms of electromagnetic radiation naturally propagate through a vacuum at this exact velocity, requiring zero acceleration to achieve it. Light and other massless particles exist perfectly at this boundary. But for humans, our spacecraft, and any other object possessing rest mass, reaching this velocity is mathematically impossible. We can accelerate a physical object to 99. Measure the speed of a passing light beam, and it always measures exactly the same, no matter how fast you're moving. Since velocity is distance over time, the only way to keep that measurement constant is if space and time themselves bend, contracting and dilating. This chart shows energy required to accelerate an object. At everyday speeds, the line is linear, but near the speed of light, kinetic energy stops generating speed and instead adds relativistic momentum. To close that final gap, an effectively infinite mass requires infinite energy. This is why brute force fails in the cosmos. The faster you push a physical object, the more the universe pushes back, turning your own engine's energy into a barrier that renders the final fraction of speed physically impossible. We can observe this physical pushback daily in particle accelerators. Facilities like the Stanford Linear Accelerator use massive 3-kilometer tracks to fire electrons at targets. Inside the Large Hadron Collider, protons are pushed to extreme velocities, circling the 27-kilometer ring at 99.99% of the speed of light. To squeeze out a tiny fraction of a percent more speed requires routing the electrical output of an entire power grid into the magnets. The particles become thousands of times heavier than their rest mass, absorbing colossal amounts of energy without going noticeably faster. These machines operate as physical proof of the asymptote, revealing a universe where matter possesses a fundamental property that resists infinite energy. Moving away from the sheer physics of mass and energy, the speed of light serves an even deeper function. It governs the sequence of events. The universe operates on causality. An action occurs, and its result follows. A star explodes, and then its light strikes a planet. The cause must always, strictly, precede the effect. If a ship or a signal could travel faster than light, it would outrun the very framework of time in certain reference frames. It could arrive at its destination before the sender even pressed the launch button, destroying the logical sequence of reality. This limit establishes the pace of reality itself, defining the maximum speed at which any information can cross space and trigger a new event. Because information is capped at this speed, everything we observe is delayed. The Andromeda Galaxy is so distant that its light takes 2.5 million years to cross the void and reach our eyes. When we look up at the night sky, we are never seeing the universe as it exists right now. We are looking backward in time, seeing distant objects exactly as they were when that light first departed. This delay turns our observatories into literal time machines. Staring deep into the blackness captures photons that have traveled for 13 billion years, revealing the infancy of the universe exactly as it was forming. This unbreakable asymptote provides the vital structural glue that preserves time, history, and the logical framework of existence.